Now let's create a calculated member that's part of a dimension. We're going to add a new calculated member just as we have always, and we'll give it a name called Other Products. Now here's what we need to do differently when we're not creating a measure calculation. We need to select the parent hierarchy, which in this case will be product and then category. And then we need to identify the parent member, which would be the top of the hierarchy. Now, if you get a message like this that says error retrieving children, that just means that you need to click the reconnect button here to have the metadata read by the designer. And then when you click the change button, you'll see the all member. Now, if you've selected a multi-level hierarchy, then you can choose any other member within the dimension hierarchy to be the parent for your new calculation. Now we're ready for the expression. Here I'm going to use the aggregate function. This is one of the statistical functions that we have available. So I could use average or max or min or sum, among various others. When we point to aggregate, we see that it takes a set as the first argument and then optionally takes a numeric expression as the second argument. So we'll drag and drop aggregate into the expression box here, and then we need to provide a set. We're going to ignore the numeric expression because we want analysis services to use whatever measures happen to be in our query or in the browser. So we will not set the numeric expression explicitly. Now there are lots of ways to create a set, but we'll just use the metadata tab to select our members of the set explicitly. To define a set, we first need to create a pair of braces. And then inside of the braces, we need to add our members. And we'll find our product category members. So there's accessories. Now notice it doesn't say the word accessories here, and that's because in analysis services we have key columns and name columns for each member. So in the case of accessories, the key column has a value of 4 if we were to look at the underlying table. And we can reference in MDX the key column by putting the key value in brackets and putting an ampersand in front of the first bracket. So ampersand 4 is the equivalent of typing in accessories, like so. Now key column values are less likely to change, so using key values within our expressions can be a good idea because we know that even if the name of the member changes later, our expression will always work. However, it's harder for people to come and look at expressions and know what those values are. So you need to decide when you're creating the expressions what the risk is of using the name column in your expression rather than the key column. To keep things simple here, I'm just going to continue by using the drag and drop, which will use, of course, the key columns. So I have a comma and then the clothing and another comma. We'll add in components. And I could even add in, just in case, the unassigned products member as well. Notice here that because the unknown member, called unassigned product, does not come from a table, we have a different representation of its name. We have a function called unknown member. Now for a format string. We need to accommodate the fact that we have multiple kinds of measures, each of which will have a different format string requirement. So it's not just a simple matter of selecting one of the built-in format strings. Instead, we need to use a conditional expression. Now we could type that expression here directly into the format string box, but it might be a little bit difficult to read. So instead, let's switch over to the script view. And here's where we see our new calculation. So let's just add in a format string expression here, and I'll just paste it in since it's rather lengthy. But you can see we have format underscore string equals, and then my case expression that looks to see if the current measure is profit margin percent, we'll use the percent format string. But if the current measure is either reseller order quantity or internet order quantity, then we'll use pound, comma, pound to show integer values with a thousand separator. For everything else, we'll use currency. And notice that each of these format strings is enclosed in double quotes. Now we may want to add in one more property. If our front-end tool doesn't know how to interpret these, it will just simply not format these values. So we can add in a language property, which in my case is 1033 for United States English. And then of course to test this, we'll deploy our project. Then we can go to the browser, reconnect, so notice here we have other products listed in our set of members available for the category attribute hierarchy. And in the sales amount column, it represents the sum of accessories, clothing, and components. Now our grand total value does not include other products. It's simply the sum of accessories, bikes, clothing, and components, without the other products. Similarly, other products in the profit margin percent column is the aggregate of accessories, clothing, and components. In the other products column, it represents the sales amount minus cost divided by sales amount. So it's correctly computed for the other products row. And that's the purpose of the aggregate function, to always work correctly with the measures that are involved in the calculation. And then also in the metadata tree, we can see that the other products appears with the other category members, but at least in bids, it's displayed with a special icon to indicate that it's a calculated member and not a member that's coming from our dimension table.